Hello everyone, I am Nishant Upadhyay, presently working at Scientific Research Center for Elementary and Applied Principles, which is known by its acronym SRCEAP. Finally today, I want to demonstrate Sir Isaac Newton's old and precious classical knowledge incorporated in relatively novel but unbeatable quantum packets of great scientist Albert Einstein. I want to provide the name of this intellectual attempt as the optimized theory of everything. Let's explore this scientific tour. In last two videos, the abstract and the first part of introduction of optimized theory of everything were covered. Now, let's start with the second part of the introduction of optimized theory of everything. In this video, introduction of nucleus is covered. Remaining part of the introduction will be covered in the next videos. Let's go through the experimental facts about nucleus. The nucleus of the atom is made up of the positive charged proton and the chargeless neutron. Nucleus has the highest mass density as well as it possesses very high energy pressure. Proton is 1836 times heavier than electron, but the building blocks of proton, that is 2 up quarks and 1 down quark, are only 17 times heavier than electron. And this is also true for neutron. This suggests that only 1% mass of quark having definite charge and spin is measured by using deep inelastic scattering techniques. According to the traditional hypothesis, the remaining 99% mass of proton and neutron, which is not measured by same experiment, is considered as the strong force field energy. Above facts indicates that only 1% mass of nucleons is sensitive for surrounding electromagnetic fields. So, it can be measured during deep inelastic scattering techniques. The remaining 99% mass present within the nucleons is electromagnetically neutral. So, it cannot be measured during the same experiment. It is indicated that the very strong attraction forces exerts between the total quanta of mass within the nucleons of nucleus because of the very low total quanta of energy to total quanta of mass ratio. So the nucleus possesses intense mass density along with the intense energy pressure. This remaining 99% mass of nucleus may possess electromagnetically neutral mass of hadrons, which contributes for very strong attraction forces not only for one another but also for surrounding dark matter. It can be hypothesized that within the normal non-radioactive nucleus, a proton is made up of positron along with electromagnetically neutral mass, and a neutron is made up of the electromagnetically neutral mass only. Due to the exposure of nucleons to very high quanta of energy during high energy experiments, minute fraction of electromagnetically neutral mass of nucleon dissociated into pair of electron and positron within a nucleon. So highly energized proton is made up of a positron along with one or more pair of electron and positron as well as electromagnetically neutral mass. And highly energized neutron is made up of one or more pair of electron and positron along with electromagnetically neutral mass. By targeting electrons or leptons to nucleons, virtual photons are created during deep inelastic scattering technique. Nucleons like protons and neutrons absorbs excess quanta of energy from virtual photon, which dissociates minute fraction of electromagnetically neutral mass of nucleon into pair of electron and positrons within a nucleon. In particle accelerator, process of hadronization suggests absorption of quanta of energy during the high energy collision between two hadrons, which suggests the dissociation of electromagnetically neutral mass of nucleon into pair of electron and positrons. By exposure of high energy gamma ray to neutron rich nucleus, electron and positron pair production is observed along with beta minus emission. Now let's understand the reason for formation of jets during high energy experiments. Due to the exposure of nucleon to very high quanta of energy during high energy experiments, minute fraction of electromagnetically neutral mass of nucleon dissociated into pair of electron and positron within a nucleon. During the process of hadronization, electrons move toward the direction having higher quanta of energy to quanta of mass ratio within Z, and the positron moves toward the direction having lower quanta of energy to quanta of mass ratio within Z. So due to the moment of both charges in opposite direction from each other, coupled with very strong attraction forces of electromagnetically neutral mass within nucleon, narrow cone-shaped jets are produced during high energy experiments in presence of very strong electromagnetic fields.